There we go. Let me turn off some of the lights in here. Oh, well, I guess all of the lights. My only choice. All right, so so the first problem on test one here, we're supposed to find the equation. So just some bigger points. So for the final exam part one, you're allowed three sheets and three pages of notes, front and back. All right. So you could bring the. Was that something from here?
Oh no.
Start making a statement or something. No. So you're allowed 3 pages of notes, front and back. And you can have solutions to old tests on there. I mean, I don't limit you. You can put whatever you want in those 3 pages. All right. Yeah, three pieces of paper, front and back, usual size. No poster board or any kind of funny business. But you can have whatever you want, all right? But you need to have those prepared before the test, right? You can't be rifling through your notes and stuff like that or trying to copy stuff off an old quiz or test during the final exam. That's not going to work. Yeah, next class is final exam part one. So anyway, problem number one here on test one was to find the equation of a line, right? So what did I do? I noticed that I have 0, 5 means the y-intercept is 5. And so then I just plug the point into the equation y equals mx plus 5 to see that the slope was minus 3. Of course, you could just calculate the slope separately and you plug that in. I mean, the way I did it doesn't have to be the way you did it, but we should all agree that the line is minus 3x plus 5. All right? So if you got this one wrong, then you should try to fix that, right? Multiply the following expressions and collect like power terms. I feel like some people got this right. I can't remember how it actually went down. But so for this sort of thing, I just multiply it out and distribute, and So I don't really have much to say here. Any questions? So these are all. This is test one, and these are all posted in. So in course content, right under tests and solutions, they're all in there, right? And also, what else is in there that's worth studying, of course, is the quiz statements and solutions, right? So here's, what did quiz one look like? Almost the same thing, right? Find the equation of a line. I mean, it's not going to be exactly the same, but same ball of wax. I don't even know what that saying means. Anyway, this didn't go well. Everyone here, pretty much without exception, needs to practice how to do these kind of problems. And the way you should practice is, try to do it without looking at the solution. Notice that I have provided for you in course content also, we're section 8, right? So here's test 1 blank. I have a blank copy of test 1. You can print it out to work on it, or you can just look at it and work on it. I mean, up to you, obviously. So you don't have to look at the solution while you work it. Or you could have the solution out but cover it. But you need to have the discipline to cover up the solution and work it yourself, and then see if you got it right. And if you didn't get it right, you got to figure out what is it that I'm doing wrong, right? And, perhaps your tutor can help you with that, right? But I think that's especially important. If I were you, I would focus my attention, at least a lot of it, on problems where I lost points, right? Don't be like me. Don't just study the part you know and then put off the part you don't know until like 2 in the morning before the test, right? Like that's not the way to do it. Don't be like the student in my other section of 101. We had a test at 2 o'clock on Thursday, or Tuesday. It was Tuesday this week at 2, and emailed me, yeah, I missed the test. I was sleeping. I slept in. Our class is at 2. It's at 2. How do you sleep into a test at 2 in the afternoon? I don't know. It just gets like that sometimes. I mean, in his defense, my brother used to be on like a 30-hour day. He'd be up like 20 hours and then sleep like 10 or 12. And he'd just do that. He'd always never be on like a normal day, like 5 days in his week when he's a teenager. He slept so much. Probably not healthy. Was it? It's all right. You probably wouldn't approve of my brother's lifestyle either, though. It's got a lot of math. It's very mathy. It's a very mathy lifestyle.
I'm never going to use this in my entire life.
You are living right now. You are using it here.
For no reason.
For no reason.
You're just wasting my life in this class right now. It's an hour and how long? 15 minutes?
At a minimum, you are providing comic relief for us. That is a valuable thing. Mostly for me. Like, they're on your side. Seriously though, do try to study the ones that you have trouble with. I really think that there's no reason that anybody here who did bad on a test can't do better on this final, right? And if you do well enough, then you don't have to take this class again, right? Which is what we would prefer. If you do, so the final exam, I will replace test 1, 2, or 3. Or all 3 of them if you do better on the final. Final exam part 1, yeah. All is not lost. I mean, you can improve your score. It is possible. Listen, so where was I? This one here. The main thing is we have laws of exponents we have to use, right? And so we just, what are the laws of exponents that we have to work with? Goodness gracious. Top of the bottom is negative, right? So if we have, also if we have like a to the s raised to the t power, we get a to the st. What you just said, if it's in the denominator and we bring it upstairs, it flips to a minus, right?
Correct.
And vice versa. And then finally, if we have a times b to the s, we get a to the s, b to the s. And sometimes that looks different, right? Like this, the nth root of a is a to the 1 over n, right? So like this one looks like, for example, square root of a times b is square root a square root of b. That's a particular, that's really just the case s equals 1/2, And then we have to, be careful to do things in order, right? I mean, so, all right, well, anyway. Problem 4. I think the big mistake people made here, as I recall, was you just basically a lot of people just dropped the absolute values and just said, oh, okay, so I'm going to solve 2x plus 3 equal to 11, basically. Or they put plus or minus 13 and didn't account for moving 2 to the other side. This step here, it's like really important to isolate the absolute value. You notice that I have to isolate the absolute value before I go to the plus minus step if I'm going to do that, right? Or I can do 2x plus 3 equal to 11 and 2x plus 3 equal to minus 11 as separate equations and solve them. Some of you did it that way, and that's also fine, right? We had two different ways we approached these back when we looked at this, but I think a lot of you just had like the 4 solution, but you're missing the minus 7 if I recall correctly. So just as a point of order, when we have absolute value equal to a number, we should either be most of the time we get 2 answers, but the other possibility is no answers at all, right? What if I ask you to solve like absolute value of 2x plus 3 equals to minus 1? What do we do in this situation? What can you tell me about the solution to this? I mean, you don't even have to process this one. You just look at it and go, wait a minute. Absolute value is non-negative, right? You can't have absolute value equal to minus. So the answer to this is no solution. I don't need to do more work. I can just look at it and go, no solution, you know? And that's something that I don't think I had on the, I may or may not have had that on the quiz or the test, but that's an example of that's an example of what could be on the final, even though it wasn't on the test or the quiz, like a logical possibility that's included in an example that we had worked out. But that's about as far as I would get away from the test or the quiz for the final. They'll be very, very similar to these problems, all right? Different numbers, but same in style. Factoring, right? So what are your strategies for factoring? Right? If there's like a common x to pull out, start with that. That's easy, right? Then once we have a quadratic, we see if we can factor it, right? So if we can factor it just through the usual methods of guessing and checking, that's great. And if you can't, you can use completing the square, right? Completing the square is a way we can always factor a quadratic. Of course, I did not do that here, but because we didn't need to, right? 20 is 4 times 5, so, and I got the minus in the middle, so that suggests x minus 4 times x minus 5. Important step, if you're unsure, multiply out your factorization and see if it actually gets back to where you started, right? Because factoring is just unmultiplying, so if we did it right, we should be able to multiply it out and get back where we started. Another important thing for factoring is the difference of squares, right? You should be always looking for this pattern. If we have a squared minus b squared as the pattern, then we know what to do, right? Like a squared minus b squared is a minus b times a plus b, right? That's the pattern. So anytime we've got a difference of squares, we know how to factor it. And that's the principle I'm using in my factoring here and here, right? 4 is 2 squared, so I've got x plus 2, x minus 2. 9 is 3 squared, so I've got x plus 3, x minus 3, like that. Now, absolute value problems involving inequalities are tricky, right? There is a big difference between less than and greater than, right? For example, let's just keep it really, really simple. If you picture, and you can think about these in terms of the number line, absolute value of x less than 5. On the number line, that's saying that you're less than 5 units from 0. So you're like between minus 5 and 5, right? This says the distance from 0 to x is less than 5. So the answer is minus 5 to 5 in this case, right? So this translates to minus 5 less than x less than 5. In contrast, if we have the absolute value of x is greater than 5 on the number line, that's saying that you're more than 5 units away from the origin, right? And so like that means you're either over here or you're over here, right? So you have x less than minus 5, or you have x greater than 5. And so those, in terms of intervals, it's like minus infinity to minus 5 or 5 to infinity. So the answer to this one, the solution to absolute value of x greater than 5 is actually minus infinity to minus 5 unioned with 5 to infinity. So notice that like the solution, the type of solution for absolute value of inequality is really, really different for less than versus greater than. Okay? There's a lot of students who don't notice this and assume that it's the same way for both. And usually people assume it's this way for both ones, but it's not. It's not that. It's not how it goes. Now, for this test, I think I was nice to you guys, right? I gave you the easy case, the less than case. But what did I do on the quiz? Did I have the greater than case on the quiz? I don't remember, but it definitely could have been greater than. That would have been like a fair question here, right? If this was instead of less than, if it was greater than, what would have been the answer? Instead of this, you'd have like minus infinity to minus 2 unioned with like 14/3 to infinity. Because there's this like dichotomy, right? If something is not less than it, it's greater than or equal to it. So if you can solve the less than problem, if you sort of like flip the answer over and like pick everything else that's not in the answer, that would be the answer to the corresponding question. But anyway. So any questions about this one? So what I did was I said, okay, so that's less than 10, so I do minus 10, less than that, less than 10. And then I simplify the inequality by subtracting 4 across it. And then I divided by minus 3, which flipped the inequalities, right? And then that's 14/3 bigger than x, bigger than minus 2, which gives me that interval. So. So one of the reasons we need to know completing the square is to figure out where the center of circles is in these sort of problems, right? So, and as I recall, I think a lot of people actually got this one right. In fact, it was strange to me because like a lot of you got this right, but you got earlier problems you got like the line problem on the start of the test wrong, but then you got this right, which is to me just like ridiculous because the line problem is so much easier than this, right? Find the equation of a line. This is something we should all be able to do. I would understand if a student didn't get this. This to me seems harder, at least. I don't know. So we take half of the coefficient of the linear term and then square it, right? Then we have to subtract the square of that, which is 49. I have to subtract the square of that, which is 25 squared over 2. 25 over 2 squared, rather. And then I move all that stuff to the other side, and after a little bit of calculator work, get 825 over 4, which shows us that the center was 7, comma, minus 25 over 2 with radius square root of that. So, yeah. Any questions? All right. So complete the square, right? So I factor the 3 out to make life easier, right? And then I take half of the x term, which is 2, I add it to x, I square it. When I multiply that out, it gives me a 4. But since I've got a 5 here, I still have to add 1 to make this equal to that. So I completed the square. And if it's a plus after you complete the square, that means that there are just complex solutions, right? So there you go. X plus 2 squared equals to minus 1, which then when we take the square root, we get plus or minus the square root of minus 1, which is plus or minus I. So the solutions were minus 2 plus or minus I. Now suppose, hypothetical, suppose you're just completely blanking on completing the square, but you still wanted to get partial credit for calculating the complex solutions of f of x equal to 0. How would you do it? What could you use? How about the quadratic formula? Right? The quadratic formula will tell you the solutions in all cases, right? But, if I ask you to complete the square, I really would like for all of you to learn how to do that, right? If the sort of abstract instructions I gave when we covered this material didn't sink in for you, like I gave some kind of description of you take half of this, you add it, you square it, you subtract it, I probably used ABC for that. If that doesn't sink into you, why don't you just take, say, 3 or 4 examples of completing the square and just put them on your formula sheet and say, this is completing the square, and try to understand it, what's happening in those examples, right? Like, what have I done? I've just taken half of that term, and the thing is, if I multiply this out, I get x squared plus 2x, which gives me 4x, plus 2 squared, which is 4. And then if I take that 4 and I add 1, I get 5. So multiplying this out, expanding this out, gets me back to there, right? That's always the judge of so we always should judge algebraic manipulations by, double checking. Is what we did actually consistent with what was in the previous step, All right, I'm going to go on. This one here, notice when we complete the square in part B, instead of getting plus, I got minus, which corresponds to the discriminant being positive, right? The discriminant on that last one would have been negative if we checked the discriminant. Hmm?
Sorry. I said
Oh.
I was looking at my test, I messed up right there.
Oh. I gotcha. So, and so here I'm just isolating the square and then taking the square root plus or minus, because I think that's an easy to understand way of solving it. Of course, the other way you could do it would be to look at this as the difference of squares and factor it, right? You could also take that approach. I think I had a problem in your homework, which was about factoring, right? So that's the sort of the third level of studying, is reviewing the homework, right? Correct. Let's see, submission 1. So, one of the things you could try doing would be working through, finding A and B for these ABC problems here, right? Without looking at the solution, see if you can do it. If you can really do that with confidence, you're probably going to be okay for that problem on the test. If you can't, there's something missing. Let's see here. Let's see here. I said complete the square and find all real or complex solutions. So, right. Huh. Oh, I didn't do it. Sometimes I ask students to factor in the complex case. Did we factor over the complexes? I know we did. Somewhere. Well, anyway, let us continue on here. Sorry, I'm distracting myself. Where were we? I got too many things open. Yowzers. I'll just close everything and start back here. So, content. All right. So this one here, we're supposed to, problem 9, we're basically supposed to find the Cartesian form of the complex number. So, in fact, I was just teaching this in Math 101. So maybe you've seen this in a previous class, right? So we multiply by the complex conjugate of the denominator, and that will remove the I from the downstairs, and so to give us what we want. Any questions about problem 9? So I think some of you weren't ready for problem 10 when test 1 happened. I hope since then you've picked up on how we solve these, because I think it's come up again after test 1, right? So the way to solve an inequality involved, like a rational inequality, is to look for all the numbers which either make it 0 or undefined, right? So the way to do that is to factor the numerator and denominator. Now, fortunately here, it was already factored, right? X plus 6 cubed, x squared times x minus 4 to the 5th. So in this context, minus 6 makes 0 up here, 0 and 4 makes this down here division by 0. So our critical numbers, algebraically speaking, are minus 6, 0, and 4. And then I just plug in some test points, and I get pluses here, minuses here, pluses here. And from that, I can solve the inequality. It's going to be over here or over there. Now, I have to think, should I include the minus 6? Should I include the 4? Or should I exclude them? So minus 6 I can include because I'm looking for greater than or equal to 0, right? Minus 6 makes this expression 0, so I can include the minus 6. But 4 is troublesome because that means division by 0. We cannot allow that, so we have to exclude 4. So, and remember, there's also a trick in terms of like creating the sign chart. If you have an even term, then that means the sign isn't going to flip across the algebraic critical number. So like I had minuses to minuses at 0. In contrast, x minus 4 to the 5th power, x plus 6 to the 3rd power, those are odd powers. That means as you go across those critical numbers, the sign is going to flip from plus to minus or from minus to plus over here. Of course, you could always just plug in 4 different numbers and see what happens at the different places, but it's way faster to use the sign flipping idea. This one here is not like the others, right? In the sense that this one is greater than 1. So if it was greater than 0, it would be more like the previous problem. But greater than 1 means that I need to convert it to a problem which is like a greater than 0 problem. So my first order of business is to make a common denominator. And then once you've done that, like here, then simplify, because you really need to be able to have it factored above and below in order to see what the critical numbers are of what you're facing. Critical numbers here are 0, minus 1, minus 3, and 3. And so that informs my sign chart down here. I plug in a point, I figure out where it's positive, where it's negative, and then I can solve the problem. And this time, there's sign flips at every critical number because they're all power 1, which is odd. So there's sign flip. And I plugged in 1 because it was easy. And I got, minus 1 times 2 over 4 times minus 2, which gave me something that's positive. It told me there was a positive in here. And then once I knew those pluses were there, I could put minuses here, pluses here, and minuses here. And then since I'm solving greater than 0, my solution is minus 3 to minus 1 and 0 to 3. And I don't include any of the endpoints because it's a strict inequality, right? I don't want the equality there. Anybody in here do the bonus?
Probably not.
I don't think I got a bonus from any of you. You could have done that. Could have been 10 points. It was due anytime before test 2. So, sorry, your time has come and gone for that one. Your time is better spent on other things at this point. Before exam, test 2. Very funny. Test 2 was on functions, right? Like, I remember functions. All right. Um, so any questions? How about problem? Anybody have any questions about problem 1? A lot of you, I think people had trouble with part C. Remember, we don't just multiply or divide or add the numbers. We have to think through it. G composed with f of 2 is g of f of 2. F of 2 is given to be 20. So that's g of 20. What's g of 20? Well, g of 20 is given to be 11. So that's 11. So, we have to think through function composition. We can't just, it's not like A and B. A and B, we add the values at 2 or we multiply the values at 2. Right? Function composition works a little bit different. Now here, I remember there was some, I think on the quiz, there was some ambiguity, right? Some of you thought it went on to, like you had some tutor who thought it went on to infinity. Remember, if I told you if I was going to have one that went on to infinity, I'd try to put an arrow on the edge of the graph to illustrate it goes on and on, as opposed to, I'll try to put these big fat dots if the end point, if that's where it ends, just to make sure we understand each other. And of course, those are holes in the graph, right? So that means that 4 is not in the domain, and -8 is not in the domain. So the domain is -8 to 4, unioned with 4 to 8. The range, on the other hand, hits everything between -6 not included all the way up to 6 included. So the range was -6 to 6. F of 4 doesn't exist. I mean, there's a hole in the graph right there, all right? F of 2 is right there, so it's 6. And to calculate the composite, we have to take f of g of 2, but g of 2 here is 2 squared plus 4, which is g of 8, which is 8. And then f of 8, well, what's f of 8? Well, I got to go over here, 2, 4, 6, 8. F of 8 is down there, it's -4 from the graph, right there. So, if you got that problem wrong, I think if you take a good look at it now, you should see you can get that problem right. It's not that hard.
Wait, I have a question about part B, number 2.
Mm-hmm. Part B? What about it?
How is 6?
These are the y values?
No, D.
Oh, D. F of 2 is 6, because when we plug in 2, we get 6.
Oh,
Yeah, 2 comma 6. The y value is 6 when the x value is 2. A case-wise defined function, we have to think about which case we're in, right? 2, where's 2? Well, 2 is in case it's between 1 and 3, right? So for 2, I have to use the square root of x plus 14, which is square root of 16, which is 4. When I'm plugging in -1, that puts me in case number, the first case, which is given by the formula 2x squared plus 3. All right? I think about a third of you gave me a pair of answers here. That's very, very wrong. So, you got to think through it. Pick the case that you're in and use that formula, all right? Excuse me. Here I've asked you to graph carefully a quadratic, right? So what did I do? I completed the square that showed me where the vertex was. 2 minus 4, it opens up. And so there it is. And then the range, of course, is basically from -4 upwards, right? Difference quotient. So here we have to take f of a plus h minus f of a, right? And so for this one, f of a plus h is 1 over a plus h plus 3. F of a is, well, just 1 over a plus 3. And I left the h outside, and then I made a common denominator. Things canceled, like the a and the 3 left me with an h. Then the h's cancel upstairs and downstairs like that. Like they reduce, they cancel out. And it just left me with minus 1 over that. So I'm trying to think, what other difference quotients? Do we have a difference quotient on the quiz? What did it look like? Oh, I guess you should study bonus quiz as well. I keep forget. I forgot we had a bonus quiz, but that obviously, you know. What's that? You didn't? I still owe you your Mad Minute, don't I? Let's see here. Maybe we can do it Thursday next week. Let's see here. All right. What's that? What about Thursday?
I think college made me dumber.
You think college is done by next?
No, I think college made me dumber. Me too. I swear, everything I do, I'm not good at anymore.
I miss some. On the quiz, problem 4 was a difference quotient, but this one I gave 2x squared minus 7 for the function. So it would be wise to study, you know, for the final exam, I might give something like this. I might give something like the one was on the test. I mean, I'm going to look at both and try to decide which is a better choice, or none. Problem 6, calculate the average rate of change. So there we calculate the change in y over the change in x. So, you know, f of 8 minus f of 6 over 8 minus 6. F of 8, looking at the graph, is 4. Because when I plug in 8, the output is 4. F of 6 is minus 6, because when I plug in 6, I get out a minus 6. And so change in y over change in x ends up being 10 over 2, otherwise known as 5. So, and that, of course, would be the same as if you drew a line from the point 6 minus 6 to the point 8,4. That line is called a secant line to the graph, and the slope of the secant line would be 5. If you guys go on to calculus, you'll talk more about that. Actually, I'm curious, show of hands, who's here planning to take like the second pre-calculus, like pre-calculus and trigonometry after this? Anybody need it? This is the end of the road for you?
Nope. Actually, it might not be. I'd be back in here.
Well,
We'll see.
I hope not. I really do. Let's see here.
Is that right?
And that's not just because I don't want to see you next semester, because I'm not teaching this class, so. No, I'd like for you guys to save your credits for things you're more interested in, right? I don't want you to burn up all your college credits to retake this class. That would be, you know, not the best use of your time, right? It's like finally something we agree on. That's right, right. Seventh inning stretch? I said seventh inning stretch? Okay. Problem 7, we're supposed to find the domain for the function here, the f plus g, and there are problems like this in the homework, right? And we spent a fair amount of time talking about this kind of problem at this point in the course. But essentially the story is figure out the domain for f, figure out the domain for g, and then the intersection of those two is the answer. So we have to look for x which makes sense for both functions. So for minus x, we need that x is less than or equal to 0. And for 6 plus 2x, we need that x is greater than or equal to minus 3. that means we need to be between -3 and 0. That's going to be our answer. Now, if you don't see that, like a good way to do is put a number line, like draw this as a number line interval and draw that on the number line and then look for where both of those things overlap. That's the intersection. And the same for the division of the functions, except that then we have to avoid division by 0, so we have to throw out the -3, because -3 gives us division by 0. And so here, remember, we studied inverse functions, and long story short, we found that if the function passes the horizontal line test, then it's invertible. And if it doesn't, then it's not invertible. So the one on the left here, this guy, is not invertible because it fails the horizontal line test. As you can see, I put that horizontal line through it and I get 1, 2, 3 points, right? In contrast, the one on the right, if I put a horizontal line through this, if I could make a horizontal laser line, I'm not doing very good, but you'd only cut through the graph at 1 point. So that means we can invert it. How do you invert the graph? How do you find the graph of the inverse function? If you're also plotting it in the xy plane, all you have to do is reflect the graph across the line y equals x, which is just a fancy way of saying take the points on your original graph. In this case, I had like -6, -6, -2, 4, and 4, 8. I chose to study those 3 points. And you just take the xy components and you flip them. That's what we found. The inverse function has the graph coordinates flipped. And so this point is kind of funny because it just flips back on itself again. This, when I flip -2 to 4, I get 4 minus 2, which is that. And if I flip 4, 8, I get 8, 4, which is that. And so this is the graph of the inverse function in this case. And we've seen that they can look weirder, right? Like if you think about more recently we talked about exponential functions. Remember the inverse to the exponential function, if the base is like less than 1, it's really weird, right? It's like they kind of like the graphs kind of cross each other in a weird, funny way. Of course, is that on final exam part 1? No, it would not be, right? Final exam part 1 covers test 1, 2, and 3, quizzes 1, 2, 3, the homework corresponding to these material, but it would not cover material after test 3, namely stuff from chapter 4, like exponentials and logs. This is forbidden. I'll get back to that on your final homework, which I have not posted yet, and the final exam part 2. All right. So here I asked you to calculate the formula for the composite of f and g and g and f, and also f with f. So any questions about this? All right. Now here I've asked you just to sort of sketch the graph of that. X plus 6, x plus 2 squared, x minus 3 times x minus 7. So we've got crossings at -6, at -2, at 3, and at -7. It bounces at -2 because of the square, right? But it crosses elsewhere. And so if you think about what that has to look like, you can see from the picture that there should be like 2 local maximas and 2 local minimas. And then here, here's an equation. Is this the graph of a function? So I think in the homework, a lot of your tutors were like, and also the people over in the next room were actually thinking you should like graph the equation. But like, okay, I mean, if you have technology, great, but you don't have it on a test, right? At least not the kind of technology you need to do that. So really what that boils down to is, can you solve for y? If you can solve for y, then, it could be the graph of a function. In this case, I can solve for y, I get y equal to that. And so that shows that there's the formula So it's the graph of f of x equals to x squared over x minus x cubed in this case. And I think logically, if you think about this, odds are pretty high that the answer is yes, because it's a much nastier question for you to prove that something is, prove, that's kind of a dirty word in here, to prove that something's not the graph of a function. Like, how would you actually show that? That would be, it's possible. There are, right. Here, I'll show you one. You're like, that's not necessary. You, she's like, apparently you don't understand the words coming out of my mouth. Let's see here. You don't think I do. How about this? Here's an equation. The whole, every test is a study guide. So, I got that you guys have 3 pages of notes. That's better than a study guide. But you don't. But if I study to make the study guide, that doesn't help you. So x equal to y squared, is this the graph of a function? And like the answer would be no. Because if we solve for y, what do we get? Y is equal to plus or minus the square root of x, right? So if when you do the algebra, you get not one solution, but 2 solutions for y for a given x, then that means that that's not single valued, right? So but that's about the most complicated, probably about the most complicated example I can think of, at least off the top of my head, where the answer is no, it's not a function, and yet you can see it by algebra. Of course, you could also see that by graphing. What's the graph of x equals y squared look like? That's a parabola that opens sideways, right? I don't guess we've talked about that much in here, but anyway. Maybe not at all. And okay, so problem 13. How do we find the formula for the inverse? Do you guys remember? This is something I hope you could have a shot at doing. It's pretty algorithmic, right? So what you do, if you do think that the formula, if you do think that the function's invertible, start by writing y equals to the formula, and then my next goal is to solve for x. So I subtract 41, and then I multiply by x minus 3. I distribute stuff. I put all the stuff with x's on one side. I factor the x out, and then I divide by that factor, and I get x is 3y minus 123 over y minus 42. And there you go. That's the formula for f inverse of y. If you want the formula in terms of x, well, change the y to x if you like. But there it is. And then I say, well, find the domain and range of f of x in the given problem. So the trick here is that, okay, so for this problem, where's the formula? Well, what's the domain for f of x in problem 13? We just look at the formula. For what x does this not make sense? There's only one, right? 3 is troublesome because you have division by 0. But otherwise, it's fine. So the domain of f is everything except for 3. Minus infinity to 3, unioned with 3 to infinity. And then the inverse function. How is the domain of the inverse function related to the range of the original function? Well, that's the thing. They're equal, right? The domain of the inverse function is the range of the function which you've inverted. So if I want to figure out the range for f of x, well, I can just figure out the domain for the inverse. And figuring out the domain for the inverse is pretty easy. You just look at the formula and go, well, the domain for the inverse is anything except for what? Except for 42, right? So that allows me to answer the next question, which was that the domain, well, I already told you what the domain was. The range is the domain of the inverse function, which is, minus infinity to 42, union of 42 to infinity. So this was a challenge question, right? Like this is something I sort of touched on in class, but maybe not that much, hardly at all. So if you didn't get this, there's certainly no shame in it. Like this was intentionally difficult, all right? And there was more than 100 more than 100% of credit on this test that you could earn too, right? Like if you had gotten everything, you'd had more than 100%. 150 is 100%. I think I had 160 points that you could earn in principal. And then, of course, the most recent test was what? Test 3. So I think you guys are still you should be pretty fresh on that still, right? So any questions here? So complete the square to find the vertex. To solve this inequality, I need to find where the algebraic critical numbers are, which I get from factoring that, -3 and 1. This one, notice that I've got less than or equal to 1, so I have to make a common denominator to convert it to inequality involving 0. And when I do that, through a quirk of the algebra, the x upstairs vanishes. So we just get the critical number at 3. If you had not done the algebra, then you might have been tricked into thinking that like -4 was a number of interest here, but it isn't. I think a lot of people got this problem right, and that was great. I was happy to see that. Let's see here. I think if I had anything, I think a lot of people got problem 5 right. That was good. Problem 6 was that was a new problem, right? So if you didn't get problem 6, I wouldn't feel too bad about it. This was the problem which I would say required new thinking. I think you had a shot at doing this because basically I've just asked you to do the problem that I've taught you how to do backwards, right? We have spent a considerable amount of time. Here's a formula, graph the rational function, right? So I just turned the question upside down. I said, here's the graph. What rational function would work? Now, there's more than one answer. And so I gave you full credit if your answer had the same vertical asymptotes as the given graph and had the same horizontal asymptote as the given graph. I actually didn't fuss at you if you didn't actually match this shape here. Like your formula could have looked like, like that or something. It could have crossed the x-axis differently. I was still giving you full credit because, like I said, I said make sure it has the same shape as well as matching horizontal and vertical asymptotes. So I'm mostly focusing my grading on, do you have the x plus 2 and the x minus 4 in the denominator? And do you also have an expression so that overall the degree of the numerator and the degree of the denominator matches up, and the ratio of the leading coefficients has to be 2, because that's what you need to get a horizontal asymptote of 2. So I had some people get, like x minus 2, x plus 2, x minus 4 for the denominator, and that was great, but then they didn't have the y equals 2. Like if you did that, I only took off 3 points. If you just told me there's vertical asymptote at minus 2 at 4 and there's a horizontal asymptote at 2, I think I gave you half credit. Right? There's a problem like that in the homework. So, but anyway, this is more or less, that will pretty well reproduce this here. You'll notice that there's a 0 at 3.5 and there's also a 0 at minus 2.5. So I could have added that to what I wanted on my wish list for your formula. And if I'd done that, then I would have also wanted to see these two features in your formula. Nobody put this, no one gave this answer in both sections. Like this is like above the level of all of the students taking this course's thinking. And that's okay. I mean, we've all got stuff to learn, but that would pretty much produce this graph. And I don't think it's outside the realm of possibility that you could have given this answer either, because we have discussed that if it crosses 0, there has to be a factor upstairs, right? Corresponding to that crossing. And if there's a vertical asymptote, there has to be a factor downstairs corresponding to that. And that pretty much guides you to write the formula. But of course, if you get more asymptotes, it gets more complicated, right? We saw a really horrible example in the homework, right? And did I bring it back up on the test? I did not, right? So factor completely over R, what does that mean? That means you must factor, like a product of linear factors. And so here, I saw some bad things. So one just helpful check, I think I said this last class, but I'll say it again. This is fourth order, right? So if you're factoring and you only have one factor, that means you're not done, right? Like when you multiply this out, we should recover all of those terms. So you need to have 4 x's in order to multiply back to get x to the 4th. What I'm trying to say is any factorization of a polynomial, like you should match degrees. If you start with degree 4, you got to end with degree 4, all right? So if you just have part of the answer, right? Suppose that for whatever reason you can't see your way to the whole answer, but you figured out that p of 0 is 0. You figured out that p of 2 is 0, right? What I would do if I were you, if you, for whatever reason, you can't see the rest of it, you could say, like, well, it's x times x minus 2, and then just put parentheses, some quadratic polynomial. And if you did that, I would give you much more partial credit than if you just write x times x minus 2 as the factorization of this, because that's just not the case, right? I mean, it's obviously not the case. Now, if you want to find what the other piece is, you could use long division, right? You could divide your given thing by x times x minus 2. That would pick up what this was as well. We can use long division to find the rest of the factorization if we know part of it, right? That's something we've done. And so a lot of you here did not take advantage of what was given. See, f of 1 plus 3i being 0 means that there is a x squared minus 2x plus 10 factor. So remember I told you put this on your formula sheet, be ready to use it. So anyway, that's how that goes. But this one here, again, the question was to factor f of x completely. Some of you just plugged in the numbers. So anyway, I think we're in reruns. I feel like I've already talked about this. I know I remember, oh, wait a minute. No, Jason, you just asked about the one question at the start of class last time, right? Well, Jason, your standing has just gone up in the eyes of heaven. I was just saying we've already done one of these problems because you asked about it last class.
Oh, yeah.
And you were lost in your phone. I figured that you. So I'm sorry about part B. I actually didn't grade part B. Everybody got full credit on this because this was just an unreasonable problem with the numerics I had here. So I just didn't count against you if you did that one wrong. And I changed the problem in class for you guys, right?
Yes.
But and then there's this problem. Anyway, I'll shut up. I know my time is up. So see you Tuesday. I will try to send another announcement about like how to think about your grade going forward. I'm trying to calculate potential grades and such. But